Assalamualaikum everyone. Okay, so now we have another application of the first order differential equation that involve the use of the linear equation. So this application we name it as the electric circuits. Okay, so we have two types of circuits. The first one we have RC circuit, and the second one we have RL circuit. Alright, so what is RC circuit? So RC circuit is a series of connection, a series connection of resistance and capacitance, and it stores energy in the form of electric field. Okay, so meaning here in RC circuit we have resistance and we have capacitance. Okay, so another one we have is RL circuit. So RL circuit is a series combination of resistance and inductance. Okay, so we have resistance and inductance. Okay, so it stores energy in the form of magnetic energy. Okay, so the difference between RC circuit and RL circuit is for RC circuit we have resistance and capacitance, and it stores the energy of electric field in the form of electric field, and for RL circuit you have stores energy in the form of magnetic energy. Okay, so let's see for the RL circuit. Alright, so as I have mentioned earlier, okay, the electric circuit is the application of the first order ODE that involve the linear equation. Alright, so for RL circuit we have resistance, okay, and then we have inductance. The resistance will be represent as R, okay, and the inductance will be represent as L. And another one we have the voltage or the energy, okay, so this is the energy. Okay, we will represent as the E. Okay, so R is in the unit of ohm, so L is in the unit of henries, and E, the energy, is in the unit of volts. Alright, so the linear equations for this model of RL circuit, okay, is given as this one. Alright, this one. Okay, so the model is L di dt plus IR equals to ET. Okay, so you have to remember all the subject here. Okay, so we have here L, it represents the inductance, okay, in henries, and then R represent the resistor, okay, in ohm, and then I is the current, okay, current is in ampere. Alright, and then we have di dt is the rate of change of the current. If you need to find the rate of change of the current, then you need to differentiate the function of I. Okay. And ET is the voltage supplied in volts or the energy supplied in your RL circuit. Alright. Okay, now let's see the example for the RL circuit. Okay, we have here a generator having EMF 100 volts is connected in series with a 20 ohms resistor and an inductor of 2 henries. If the switch is closed at time t equals to 0, set up a differential equation for the current and determine the current at time t. Alright, so if we represent here, we have the 100 volts here is your energy, okay, and then we have ohms, okay, you just identify the unit, okay, so we have ohms is for the resistor, okay, and then we have at time t equals to 0, the switch is closed, meaning the initial condition here we have I equals to 0. So here we say that your initial condition, okay, when t equals to 0, I equals to 0. Okay, and then we need to set up a differential equation for the current. So the current means here we want to find the IT. What is your IT, or what is your I in terms of t, and determine the current at time t. Okay, so we have here the linear differential equation is L di dt plus IR equals to ET. So just substitute all the value for each term. So we have your L is 2, and then the IDT, and then I, so I we just leave as I, so because we want to find the formula of I, and then your resistor is 20 ohms here, and then your energy is 100 volts. Alright, okay, so this is the information that we have. Information from the question. Okay, all right. Next we will simplify. So since you have the constant here, okay, or since you have the coefficient for your didt, so we need to write the coefficient as 1. So what we have to do is we will divide all with 2. So when you divide all the function with 2, then you will get 2 over 2 didt plus 20 over 2I equals to 100 over 2. Okay, and lastly you will get the linear differential equation for this case is didt plus 10I equals to 50. So now let's compare with the general form of the linear equation. We have here didt plus pt, I equals to qt. So what is your p? This is your p, 10. And what is your q? Your q is 50. Okay, class? Okay, now let's proceed with the next step. Okay, after we have identified the p and q for this linear equation, we need to find the integrating factor, or we call it as the IF. Okay, so the formula for IF is the exponent to the power of integration of pt dt. So your p is 10, and then when you integrate 10 you will get 10t. So your integrating factor is this one, e to the power of 10t. Okay, next we will multiply the integrating factor on the both sides of the equation. So the d dt e10ti, okay, equals to 50 e to the power of 10t. So this is your q. Remember, this is your q. Okay, so it should be this one, d dt I times with the integrating factor equals to q times the integrating factor, right? Okay, so next we will integrate both sides of the equation. Okay, when you integrate both sides, you will get integration of d dt e to the power of 10t times I, or you can also write I in front of e, so it depends on you, and then equals to integration of 50 e to the power of 10t dt. Okay, so now you will neutralize your integration and differentiation of d dt. So you will get here e to the power of 10t times I equals to, so integrate 50 e to the power of 10t, you will get, so 50 will be right outside here. Okay, so 50 outside here, and then the integration of e to the power of a t or ax. Okay, so integration of eat dt, it will be 1 over a eat plus c. Okay, that's why we have here 1 over 10 e to the power of 10t plus c. And then we will simplify, and lastly, don't forget, please write your I as the subject When you write I as the subject, then it means you will move your e to the power of 10t to your right hand side. So we have here 1 over e to the power of 10t times 5e to the power of 10t plus c. Okay, so lastly, your it is 5 plus c over e to the power of 10t. So this it, so we write as it here. So it is actually the expression of I at any time t. Okay. Continue, we want to find the value of c. So by using the initial conditions, we have when t equals to 0, I equals to 0. So you will get here your c equals to -5. And lastly, you will get the current at any time t, that is it, equals to 5 minus 5 over e to the power of 10t. So this is the final answer for this question. Alright.